Okay, we're here to do just a couple more examples with solving using the quadratic formula. So first, let's write down the quadratic formula. We're going to need to refer back to it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There's our quadratic formula. Okay, and we're going to write that down a couple more times too. Okay, first additional example. Let's solve. And we're going to leave in simplest radical form. Simplest radical form. You get the idea there. All right, so we're going to do x squared plus 8x plus 5 equals 0. So I can't factor this. I know that because it's a regular trinomial and there are not two numbers that multiply to 5 and add to 8. So I know I can't factor this, so I'm going to use quadratic formula. Step 1, is it in standard form? Sure is. Okay, so I can move past that. So I should identify A, B, and C. A here is 1, B is 8, C is 5. A, B, C. So I'm going to start plugging into the quadratic formula. So x equals negative b. Well, 8 is positive. B is positive here. So negative b is going to be negative 8 plus or minus the square root of b squared. That's 8 squared minus 4 times a is 1 times c is 5 all over 2 times 1. Okay, so this is going to be negative 8 plus or minus the square root of, and now I'm going to go to my calculator, and I'm going to have 8 squared minus 4 times 1 times 5. And that gives me 44. And that's all over 2 times 1, which is 2. All right. So in your next step, you should simplify your radical. So x equals, and the reason why I'm going to simplify my radical here is because the directions say simplest radical form. If the directions didn't say simplest radical form, if they said round to the nearest tenth, the nearest hundredth, then there's no point in simplifying. But since this says to simplest radical form, now I'm going to simplify. So you should know how to simplify, but it turns out that this is going to be 4 times 11. 4 is my perfect square, so that's going to be 2 radical 11. You should know how to simplify. I'm not going to go through those steps. You already know how to do that. And this is all over 2. And now I can reduce. Negative 8 reduces by 2. 2 reduces by 2. So I have x equals negative 4 plus or minus 1 radical 11 or just radical 11. Okay? Now you can write it in this way, or you could write x equals negative 4 plus radical 11 and x equals negative 4 minus radical 11. Remember that plus minus means that one of my roots is a plus and one is a minus. Okay, so that's all that means. There's your answer right there. That's simplest radical form. And to check this, well, let's be honest. I mean, one response would be, okay, take this and plug it in for x. That's going to be pretty hard to plug in for x. Negative 4 plus radical 11. That's going to be kind of hard to. So let's check this using the calculator in a different way. Let's go to the y equals, clear out anything that's there. Let's put our original in, x squared plus 8x plus 5. And then let's go to the graph of this. Okay, there's my solutions. Remember, that's what we're looking for. Okay, these solutions that I'm finding are where this thing crosses the x-axis. Now, these are irrational, so remember I had to use this second trace tool. So I'm going to do second trace, choice 2 for the 0. I'm going to do my left bound and my right bound. Keep going, keep going. Find the spaceship, as Miss Glanton likes to call it. There it is. Okay, so that's on the left-hand side. And now I have to do the right-hand side. And then my guess, I'm going to get as close as I can. And I just want to show you something. Check this out. So we got, just as a check, we got x equals negative 7.316625. Check this out. Watch this. Go back to a regular screen. And let's put in this one right here, negative 4 minus root 11. Negative 4 minus the square root of 11. Check that out. Negative 7.316624. That is amazing. Now we could go through the process of doing the other one. We could go back to the graph, redo the process, figure out what this is, but you can probably guess if we go through that process and figure out what this solution is, it's going to match the negative 4 plus root 11. We won't have to go through that, but that would be a way to check this. Okay? All right, let's do one more where we're going to round to the nearest tenth instead of leaving in simplest radical form. So here we go. Let's take this out. And let's try. We're going to solve. This time we're going to round to the nearest tenth. And we're going to do 3x squared plus 5x equals negative 1. All right. First things first. Is this in standard form? No, it's not. This is supposed to equal 0. So I'm going to add 1 to both sides. Let me switch pen colors here. I'm going to add 1 to both sides. And now I'm working 3x squared plus 5x plus 1 equals 0. Okay, now I can start actually working with this. So I got to identify A, B, and C. In this case, A is 3, B is 5, C is 1. And now I can start plugging in. X equals B is 5, so negative B is negative 5, plus or minus the square root of 5 squared minus 4 times 3 times 1. A is 3, C is 1, all over 2 times 3. Next line, I'm actually going to figure out what all that is. 5 squared minus 4 times 3 times 1. Enter. That's 13. So that's 13 all over 2 times 3, which is 6. Now, this one says round to the nearest tenth, so I would not proceed to simplify this, although radical 13 is already in simplest form. But even if it wasn't, there's no point in simplifying this. Instead, let me branch off into 2 separate roots here. I've got x equals negative 5 plus radical 13 over 6. And I've got x equals negative 5 minus radical 13 over 6. Okay? And instead, I'm just going to put those in the calculator and get a decimal equivalent. So I'm going to do it in 2 steps. So I'm going to start with this top one. And I'm going to do it in 2 steps. Negative 5 plus radical 13. Hit enter. Divide by 6. Enter. And I have rounded to the nearest tenth, negative 0.2. And then in the bottom, I've got negative 5 minus radical 13. Enter. Divided by 2. Enter. And I've got rounded to the nearest tenth, negative 4.3. So there would be my solutions. This time I'm going to write it in set notation, just to be different. So I've got negative 4.3 and negative 0.2, and those would be my solutions. Now I could check those. I could substitute them in for x and into my original and make sure I get something that's true, or we can use that graphing method that I just showed you. So hopefully these examples help you out a little bit as far as understanding how to use the quadratic formula. Certainly you're going to get plenty of practice in class.